Okay guys, so this is going to be a lesson over evaluating limits analytically. When we talk about evaluating limits analytically, we're talking about using algebra techniques. So pretty much what we're going to be doing is we're going to be plugging in whatever the limit says to do into the expression. Now, some key things is if it looks like it factors, it probably does, so maybe try factoring. If you get 0 over 0 when we plug in, initially. So say you get a fraction that gets 0 over 0. That means you have to simplify it, okay? So you would have to factor and cancel something. So just keep that in mind as you're working through. Anytime you get 0 over a number, the limit's 0. If you get a number over 0, like 5 over 0, that's going to be does not exist, okay? So just make sure 0 over 0 means you have to simplify something. Okay. So as we go, the limit as x approaches -3 of 1 minus 5x. So all we're going to do is we're going to plug in 1 minus 5 times a -3. Okay. So -5 times -3 is 15. 15 plus 1 is 16. Okay. So if I was to plug in a 3 right here, 3 squared is 9. 9 minus 9 is 0 over 0. I'm not going to do this every time. So and then 3 minus 3 is 0. So I get 0 over 0, so you have to simplify. This is what I was talking about. Okay? So it's just easier to know that this is difference of squares. So let's go and factor it. So difference of squares factors to x plus 3, x minus 3 over x minus 3. These would cancel. So you would have a hole in that graph, a removable discontinuity. Okay? And then now I just take this 3 and I'll plug in whatever's left over. So this comes out to be 6. Okay, next one. We're going to plug in a -2. So a -2 squared plus 2 times a -2 minus 15. -2 squared is 4. Minus 4 is 0. 0 minus 15 is a -15. Okay. Next one. There's nowhere to plug in an x, so your limit is just equal to 7. Next one, plug in a -2. 4 times a -2 cubed plus 1 all over -2 minus 5. Okay, so a -2 cubed is -8. -8 times 4 is a -32. -32 plus 1 is a -31. -2 minus 5 is a -7, so 31 over 7. Okay. Next one, we're going to plug into the square root. 2 plus 4 is 6, so this is square root of 6. Next one, top looks like it factors, so we're going to factor this to x minus 5 and x plus 4 all over x plus 4. The x plus 4s will end up canceling. Then I'll plug in my limit. So -4 minus 5 is a -9. Okay. This one, the bottom term looks like it factors by grouping. So we'll group the first 2 and the last 2 terms together. Okay, so that's how it factors. So we get x minus 3 over x squared minus 7 and x minus 3. Okay, so the x minus 3s will cancel. Now pay attention to this because this is where people are going to mess up. When something cancels top and bottom, you still have a 1 left on top. Okay, so 3 squared is 9. 9 minus 7 is 2. So this becomes 1/2. Okay. I want to evaluate the limit as x approaches 2 of this piecewise function. So what I'm going to do is I'm going to plug a 2 into both branches of this piecewise function. So we're going to plug a 2 into the top branch. So the limit as x approaches 2 from the left-hand side, which is the less than branch, okay, is going to be 2 squared is 2 squared is 4. 4 plus 5 is 9. And then I'll take the limit as x approaches 2 from the right-hand side, just like we did in the previous lesson, okay? The greater than branch is going to be coming from the right-hand side, so I'm going to plug a 2 in. 2 times 2 is 4. 4 minus 7 is a -3. they don't equal each other, so the limit as x approaches 2 of f of x does not exist. Okay? Okay, next page. We're going to plug in a 1 into x squared minus 1. So 1 squared is 1. 1 minus 1 is 0. Okay, so we got x plus 2 over x squared minus 4. We're going to factor by difference of squares. Okay, so x squared minus 4 factors to x plus 2, x minus 2. X plus 2's will end up canceling. And then I'm going to plug in a negative 2. Okay, so a negative 2 minus 2 is a negative 4, so this comes out to be a negative 1/4. Plugging in a 3 over here. So 2 times 3 cubed minus 10 times 3 plus 1. Okay, 3 cubed is 27. 27 times 2 is 54. So we get 54 minus 30 plus 1. 54 minus 30 is 24 plus 1. Gives us a 25. Now, you notice how I'm not using a calculator on this, guys. You need to be able to use it to do this without using a calculator. The limit as x approaches 4 of pi, there's no x to plug in, so it's just pi. Okay, this one we're probably going to factor on, so let's go ahead and try and factor this. I think the bottom factor is right. Okay. Let's see if we can factor it. So 2x and x. Factors of 15 are 3 and 2. So minus 3 and plus 5. Like that. If you want to do PSF out to the side, that's fine with me. 2x squared minus 6x plus 5. Yeah, that works. Okay, so your x minus 3's will end up canceling. And you get 1 over 2x plus 5. Okay, so we're going to plug in a 2. 2 times 2 is 4. 4 plus 5 is 9. So this is 1/9. Okay, if I plug in a 0, 0 squared is 0. 0 plus 16 is 16. Square root of 16 is equal to 4. Okay, so let's factor on these. So factors of 6 that give you a negative 7, that doesn't factor. Okay, so I know that doesn't factor. If this was a positive 6, it would factor, but it's not. So let's plug in a 6. So we get 36 minus 42 minus 6 all over 6 squared is 36. 36 times 3 is going to be 108 minus 66 minus 42. I guess it does factor. Wait. 3 and 2, no. 36 minus 42. Yeah, minus 6 is a negative 12. Yeah, that's right. Negative 12. I was thinking it was positive. Sorry, my bad. 108 minus 66 minus 42 comes out to be 0. Okay, so this is the first one where we've got a number over 0. So this is going to be does not exist. And because we have a negative number over 0, it's going to go to negative infinity. Okay. Okay, next example. We're going to have factoring by grouping on top. We're going to group our first two terms together. So x squared times x minus 3. And we're going to pull out minus 4 and you get x minus 3. So this is going to factor to x squared minus 4 times x minus 3 all over x plus 2. Now, we still have a difference of squares right here, so we're going to factor that down some more. Okay, so the x plus 2's will end up canceling, and then I'm going to plug in my negative 2. So negative 2 minus 2 is a negative 4, and negative 2 minus 3 is a negative 5, so it comes out to be 20. Okay? Just like we did the last one on the previous page, we're going to do a left-hand limit and a right-hand limit for this piecewise function. So the limit as x approaches 0 from the left-hand side, and the limit as x approaches 0 from the right-hand side. So we're going to plug a 0 into the top branch, and we should get a -5. We plug into the bottom branch, we should get a -3. Since they don't equal each other, the limit as x approaches 0 of f of x does not exist. Okay. Now on to the back page. Okay, so top question is going to be something that we call a conjugate question. Okay, so you will have conjugate questions in calculus. A lot of times if they give you a limit question, it will look like this. Okay, so what we're going to do is we are going to get rid of a to get rid of something like this, we're going to multiply by the conjugate. So the conjugate of the bottom, just like when we did imaginary numbers, is square root of x plus 2, like that. Now, what we do when we do conjugate questions is we leave whatever we're multiplying that doesn't contain the conjugate alone. Okay, so x squared minus 16, we'll leave it like that, times square root of x plus 2. And square root of x times square root of x is x. -2 times 2 is -4. Now the whole goal is to be able to cancel something top and bottom. Now I know this difference of squares will factor to x plus 4 and x minus 4. So the x minus 4s will end up canceling. So we'll do the limit as x approaches 4 of x plus 4 and square root of x plus 2. Okay, so I'm going to plug in a 4. 4 plus 4 is 8. And square root of 4 is 2. 2 plus 2 is 4. So it comes out to be 32. So review what a conjugate is. A conjugate is the same thing, but you're just changing the sign. Okay, so I know to use a conjugate to multiply whenever I'm dealing with a square root plus a number or a square root minus a number. Okay, and the last one. So this is going to be a doozy. The limit as h goes to 0 of x plus h quantity cubed minus x cubed over h. Okay, so we know how to mentally FOIL out x plus h quantity squared. So I'm just going to deal with the first part of this. I think we can all agree that this is the same thing as this. Squared times 1 power would give you to the third power because we add the exponents. Now we can mentally FOIL this out, square the first, take the 2 in the middle and double it, square the last, like that. Now we're going to have to distribute. Okay, so I like to do everything to the first term, then everything to the last term. So x squared times x is x cubed. 2xh times x is 2x squared h plus h squared x plus, I'm going to go to the last term, hx squared plus 2x h squared plus h cubed. So that's what this whole first term comes out to be, minus x cubed, and we're all going to be over h. X cubes will cancel, and then everything else has an h in common, so I'm going to factor out an h. And you're going to see this definition many times within the first couple weeks of calculus when we do definition of a derivative. Plus h squared. Okay, so your h's cancel and you're left with that. So we have to take our limit now, the limit as h goes to 0. Okay, so anything that contains an h is going to go bye-bye. So your answer should be 3x squared, because we combine our like terms. So this is actually a definition of a derivative question. because the definition of a derivative is the limit as x approaches, the limit as h approaches 0 of x plus f of x plus h minus f of x all over h, okay? So this has been doing limits analytically. So make sure you plug in, factor when necessary, and if you get 0 over 0, you have to simplify. If you get a number over 0, it's going to be undefined. And if the 0 is on top, 0 over a number, it goes to 0. Thanks, and have a good day.